All right. So what I will tell you is, like I say, your first quarter grade is done. There's no changing that. However, if it's really depend on how you finish this class. I have seen kids start out slow and they finish strong. And those are the kids I have more respect of than people who start strong and finish weak. So it's kind of like a football game. Have you ever seen to go to the football game where in the fourth quarter all the football player goes like this? You guys know what I meant, right? Fourth quarter. That's where you're gonna start working. You're gonna start working hard, and you're gonna start knowing how to finish. You gotta know how to finish the game, which is end of the year at May. How you gonna finish that course? You start slow, it is okay. Depends on how you finish it. You know, if you finish strong, you'll get a 5. For example, last year we have Harmon, who failed first 3 quarters. And literally, Asim's right there with him. Asim failed all the tests. What does that do to him? He learned how to fail, he learned how to adapt, he learned how to get better. And then by third quarter and fourth quarter, those kids that used to fail my class actually end up earning a 5 on AP exam. And there are people who start with really high grade, and by fourth grade, they start slacking off and they actually earn low grade. So each grade, each quarter, I want you to get stronger and tougher. I don't want you to get weaker. So I have seen in this class, like Sam is one of them. She hated when she come here. I can see that her emotion is like just distraught every time she walk into my classroom. Now she's like actually excited to be here, which is I'm glad. Because that mentality shift is gonna affect how you perform. And I promise you that's how the way it is. Okay, so now we're going to talk about certain things that I thought is very, very important is the projectile motion. Now, what I heard on TikTok, I went to look at TikTok and I see a lot of SAT question. And so I thought this one particular question was super phenomenal. And I think that was the best question ever written on PSAT. So that question says this. So I'm going to show you my iPad screen. So the question says, a thing is being shooting up straight in the floor, right? And it's shooting up directly, go up, and then come back down, right? It shoots straight up. And one other information given to you is the maximum height. So this is on the TikTok. I just take the question, take it from the TikTok. The maximum height says 3164. And that was the maximum height. And it takes 14 seconds to get to maximum height. 14 seconds. It's actually 14 seconds. And not only that, that takes 14 seconds to get there. The question says, you know, how high, sorry, not height. How high is the object at t equal to 1? Now, I'm not going to answer this question. I'm not going to tell you what's the right answer. I want you to start thinking about what is the answer is going to be. Very, very, very good question written by PSAT. And it's also all over the TikTok. On TikTok, I also saw the mixture question. I thought it was really good too. And I thought that was very, very phenomenal questions. Now, this one is the best one I've ever seen. Super excited about this question. When I saw people posting a solution there, I thought it was great. Now, before that, we're not going to talk about that. Before that, we're going to show you a, let me see, how can I show you this? I'm going to show you my computer screen of this. And I'm going to go to change this to iPhone. And oh, that's good. That's good. So it's gonna be me and my unorganized desktop. And I'm gonna play this. Wrong grass made me look fat. Thanks. Now, what happened here, right? This is really, really cool. What happened here is soon as the marker left my hand, it doesn't matter how much energy I exert to that, it's nothing related to the marker anymore, right? And then when it go up, so I hear what's my velocity? My velocity is positive or negative. Positive because it's going up, right? But what happened is I this? My velocity is what? 0. And what happened here? Now go back. Come back. Go. This moment here, the marker is at a peak. Do you see that? Mm-hmm. And my velocity is not going up or going down. Very important. Maximum height, my velocity is equal to 0. Yes.
And then we're talking about a vertical.
Yeah, vertically. Yeah. Vertically, no, horizontally, the marker is going a little bit forward. Yeah, so good. Thank you for stressing that. Vertically is gonna go up and just stop there, and velocity is not go up and down. So let's go out and go through this marker again, right? So this is what happened. Now, with that being said, that's great. Make sure when I go to iPad, I need to change the stream to the back to the iPad screen. So also, I want to ask you, how many of you guys taking physics? Raise your hand here. You are taking it? Who's not taking it right now? Raise your hand. Okay, good. We got 4 people didn't take, and we're gonna ask those 4 individuals. We're gonna talk about some basics about physics, right? So let's say basics. If I know a baseball, if I take a baseball, and if I take a baseball, and then if I take baseball, and if I take a steel ball and drop exactly same time on the tower, okay, steel, like iron steel or gold, same size, same exact size, and you drop exactly same time. So what I'm gonna do is I'm gonna do actually free fall. I'm gonna go like this. Which one's gonna fall on the ground first? Those who don't take physics to answer this question. Steel. Nicholas, what do you think? Steel, again, because everybody says steel, you don't want to say different, right? Now let's ask the people who already take physics. Let's say Mason, what do you think? Same time. And anybody else?
Can you say the question one more time?
If I drop a steel ball and a baseball, which is steel ball is much more heavier and more dense, more weight. Okay, if I let go at the same time, which one's gonna fall on the ground first? Free fall, without exerting any force. That just means I'm not going down, I'm just let it go, right? Yes.
So it's actually, I don't know why, but when you do like with the kinematic equations, it would be the same because like mass doesn't play a factor in there. Mm-hmm. That's my reason.
So you think it's the same?
Yeah.
Okay, Riba?
If you factor in air resistance, it's different, but if not, it's the same.
Well, the steel ball and the baseball, that there's the air resistance is insignificant.
It's the same.
It's the same. Okay, so now here's my question to you. Potassium is a great YouTube content creator. He went to ask a 3rd-year physics student. He says, which one's gonna fall faster? And you know this kid's 30-year physics. But he says, do you really believe that? The kid told him says it's gonna be at the same time. But potassium, the guy asked him, says, do you really believe it's gonna fall at the same time? Instinctually, that in any human being with the right mind would not believe they fall at the same time, because one is way heavier than the other. It should fall way faster. Don't tell me, besides your physics teacher told you, besides the formula, you're gonna feel that baseball is gonna land at the same time as the steel ball. There's no way. If you ask a non-physics student, they will tell you instinctually that doesn't make sense. It won't even make sense even you study physics. Is that true? So I saw Vatazian, he asked all the students who are major in math, major in physics, he's like, do you really believe that? Right? Really, really believe it. So here's the thing. Instinctually, I still don't believe it. And even I see it in front of my face, I still won't believe it either. I just feel like the steel ball is going to be slightly faster. Fall on the ground. So that is the precursor of all the story. Now, if I were to drop a ball and a feather at the same time, which one's going to fall faster?
Ball.
Everybody agree with that. Why?
The feather's just way lighter.
The feather will float around.
Feather is not really weight letter, but it's going to be like this.
Wait, that's the air resistance.
Yeah, that's an air resistance. That's why when you jump is skydiving, right? When you jump from very far in the air, like very high in the air, when you jump, there's actually a terminal speed, because your body is actually, you expand your body, you actually pushing your force up where gravity is going to go down. So eventually it's going to offset. It has a terminal speed. That's how fast the maximum speed you're going to go, because your air resistance, that's kind of quite interesting. Give me a sec. So feather and the ball drop at the same time. Now we compare feather and bowling ball now. So is that always true?
On Earth.
On Earth is always true?
I'm asking, is this all? Are you saying it's all?
We're talking about on Earth, yes. Is that always true? Why not?
You put in like that vacuum.
You saw the video.
Yeah.
You saw the video. So that's exactly the video I want to show you. So I'm going to show you the video of this guy did a video versus feather. Hey, look, that's my channel. I recommended my own channel, right? That's unbiased. So this guy went to NASA, and they have this vacuum chamber built up, which is crazy.
Galileo's experiment was simple. He took a heavy object, the light one, and dropped them at the same time to see which fell fastest. Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air
I love the way this guy speaks.
So in order to see the
How to
true
say
nature
air?
of gravity,
Ah,
we have to remove the air.
amazing. Now I'm gonna tell you a joke. Everybody know Edison, right? On the swim team, Edison Stump. So she was watching this video. It's like, yeah, he's like, you know what? It would be funny if the guy is inside the chamber, and everybody look at her. It's like, what's wrong with you? And she's like, what? I'm just saying the fact. And somebody asked her, say, do you know what happened with the guy that stayed inside the chamber? He's like, no, I don't know why. I was like, God, Edison.
It's like being in space, right?
Well, what happened is they're gonna suck up all the air, and it's not only there's no air, the pressure is gonna be very, very high. So I don't think a human body can handle it, and that's a one thing. Yes.
When you hide it, there's no air.
Do you remember the formula for the gas law?
Drop 2 millitorr in like 30 minutes. But once it's complete, there's a near perfect vacuum inside. Station 1, go for drop. PCP 30-1, pressure set point 240
30-to-1 pressure.
Okay, roll the die. 10, 9, 8, 7, 6, 5, 4, 1, 2, 1, release.
Beautiful.
Okay. Oh, it's kind of like all.
Is this in real time?
This is slow motion.
Thank you.
Now look at those people. Those people study science all their life. They know it's true. They know it's true without, but actually to see it in their own eye, it's truly astounding by those people. It's truly changing how these people look at this guy work at NASA. He knows that's gonna be fact. But to see it in actual life situation demonstration, they never run this experiment until this moment. They run this experiment to help out this guy for BBC, and it was very, very phenomenal, I thought.
Exactly what happened. Exactly the same. Isaac Newton would say that the ball and the feather fall because there's a force pulling them down. Gravity. But Einstein imagined a scene very different. The happiest thought of his life was this. The reason the bowling ball and feather fall together is because they're not. They're standing still. There is no force acting on them at all. He reasoned that if you couldn't see the crack, there'd be no way of knowing the ball and feathers were being accelerated towards the earth.
Wait.
So he concluded
Yeah, second time you're just standing still, there's something.
Okay, so so this is a truly amazing. I thought that even you don't appreciate math, you should appreciate this video in like the most fundamental way. I thought like you don't have to appreciate math. I can understand you don't appreciate math, but this just truly I think is very very, very cool. Very cool. So let me quit this and let me start with new QuickTime. Yes, Daniel.
Oh, alright. So let's say we dropped a book and a baseball, right? Would they hit the foot at the same time?
Yeah.
No.
But the book depends how wide the book is, right? So the more wider the book, the more error resistance. So there is no if like the book is about this far, this room enough, right? Compared to a small baseball, but this depending how thick that book is also, but it's gonna create more error resistance. So sometimes error resistance is gonna create the small difference, right? So that is something that you should pay attention to. Yes, Rebuff.
In the video, when they dropped the like both of them like without the air resistance, the bowling ball made an indent in like the cardboard box at the bottom. But then like in the like when they did do the vacuum, the bowling ball was the only one that made the indent, even though it was the same like speed coming down. How come like the feathers didn't make like I don't but like it came down at the same speed though, right? So
Yeah, but it's heavier. It doesn't matter. I beat you. Okay.
no, I get that, but like
So he's saying like in the moon, if I were beat you with a baseball bat, you should not get hurt.
no.
Let's
No, actually, I get
On the moon you would, because like
You,
wait, but that's not true. But
it's not zero gravity. It's 1/6 of the gravity of Earth. I don't know. That's an interesting question. There's a lot of questions that need to be answered, right? So that's why some of you guys need to be scientists to answer those questions that I cannot answer. But yeah, I actually don't know what it is. So this is an interesting question. So this question starts with maximum height is 3164 in 14 seconds. How high is the object at t equal to 1? I thought this question could write it better. I think this question can be without a maximum height. I think this question could be phenomenal. I think this question could be like a very, very interesting question. So when I see it in TikTok, I thought this is a great question. How about without maximum height? We're gonna solve this problem without maximum height. Okay.
What about the seconds? It gives you the seconds?
They give you 14 seconds. Yes, that's only giving. And what happened at t equal to 1? So let's teach you how to solve this problem. Let's teach you how to solve this problem. I thought it's great. I'm usually like my teaching lesson never the same all the time. Something are the same. That this is the first year I'm making some changes because I saw this video and I was, you know what, this is a good teaching material. And let's use this as a material. Let's teach things the right way. So let's talk about the right way first. Give me a second, Danny. What was your question, by the way?
Well, it was about the book thing. I was asking like what makes like a sheet of paper, you know, versus a book like, about that same size. What makes the sheet of paper fall? Or like a stack of paper or something?
Yeah, it would be slower because so when you open up your body, when you do like a jump from the skydiving jump, when you open up the body, you're gonna slow down your velocity because of more air resistance. So the wider the surface area is gonna slow it down. So if you want to go faster, you're going like this. Have you seen those like yeah, skydiving, they go like this. It's gonna go way faster compared to like this. This is how they slow down. This is how they gonna speed up.
Kind of what I mean though is like, all right, see this sheet of paper, right? It says it's about as big as this book, right?
Mm-hmm.
Like, but if we drop them, then the book's gonna hit the ground first. And so, what does thickness have to do? Do you know what
It's like
understand?
less resistance acting on the book.
Well, the wider is gonna have more surface area. The more surface area is gonna slow it down. So the only thing that factor is the surface area. The impact, at least the air-wise, the more surface area, the more slower it's gonna get. That's probably gonna sums up. But hold that down. We can answer that like after class. Because I don't know a lot of physics to answer your question. I will tell you though, there were 3 teachers in my life that made me want to become a teacher. I will say first is my calculus teacher, Miss Potts. Miss Potts is, I want to give her a shout out. Hopefully she's watching this video. She changed my life. I went to her class when I take AP calculus already, and I take AB and I failed it. I got a really bad teacher. The only thing I know how to do is derivative of x squared after the whole year. And I have, because he's like a Scottish guy, he just make funny jokes all the time, but he never did any teaching. And so all the girls love him, but yeah, it's kind of like weird because he's like 60 years old. Because they love his accent, a Scottish accent. So when I went to Miss Potts, I drive an hour to go to Dr. Phillips, and then she was the only teacher that told me the truth. And I thought I was smart. I already take this class already. I should get an A, and I got a 56 on the test. So I went to her, and she's like, says, you know, how come I got 56? She just flat out says, you are not good enough. Speak of emotional damage. I'm glad that term never existed at 1990s. But that was emotional damage right there. And I'm going to say, you are not good enough to beat my class. That's what she said. Now that teacher will probably get fired for saying that. But that's how crazy it is. That's the teacher one. So she have every single student got a 5. 60 student take it, 60 student got a 5. We all finished before time's up. Everybody's like, this is so bored. We finished 20 minutes before the test end. We finished all the FRQ, all the multiple choice. We have 20 minutes left to spare. None of the people was holding a pencil when the time's called. Everybody got a 5. Second teacher is Water Dewin. The professor is Walter Lewin. So if you want to look it up, Walter Lewin is it's another professor. I gotta show you in a second, but I'll show you after class. And the third teacher is Walter Lewin, Miss Potts, and there was another teacher named Ron Clark. That was another teacher that, yeah, go ahead. So in this movie, Journey to Center Earth has this scene in the movie. You seen that movie before? Yeah. Okay. Do you know which scene I'm talking about? It's a cliff, and he doesn't know how deep the cliff is. Yeah. So he have 400 feet of ropes, 400 feet of ropes, and he tried to says, well, we don't know how far the cliff is. How did he find out how far the cliff? Good, you saw the movie. So in the movie, he dropped something. And because it's the center of Earth, he had to drop a glowing stick. Because that way he can see where it dropped to. And also he had to connect to something heavy, so create sounds. Now sound is traveling a lot faster. So sound is traveling around 747 miles per hour. So in this case, sound is insignificant. The sound is insignificant. It's a very small margin of error. So the thing is, you only have 400 feet, but if this cliff is 1,000 feet, that means he climbed down, he's going to be right in the halfway. And that's going to be a problem because he's going to climb back up, which is going to be a bigger issue. So he had to create something. He had to make sure the rope is not enough for the cliff. Okay. So that's the first situation I'm going to introduce to you. So this is the first problem. So Noming says, you can just measure the time. Well, which equation did he use? How did he know that he knows that the things, how much time, let's say it's 10 seconds. Does that mean anything, right? Does that mean how long? So it turns out there's a physics equation called free fall. But before we do free fall, we're going to talk about something else. We're going to talk about gravitational constant. So what is gravitational constant? We know it's G. G is what? Can somebody tell me G is equal to what? Nicholas, do you know? You raise your hand first. Yeah.
I think it was me.
Oh, it was you. Okay, rebuff, go ahead.
Negative 9.8 meters per second.
Negative 9.8 meter per second square. Okay, good. All right, great. Okay, do you know that this is only used in physics class? But in math class, we never use this value. In math class, in calculus and algebra 2, we use a different value. So G is equal to, this is the value that we're going to use, is equal to negative 32 feet per second. I don't know, we're still in imperial system. For calculus and algebra 2 and SAT, they always use negative 32. But I heard AP Physics uses 10, which is kind of weak, I think. You're not supposed to use 10. In college, you use 9.8. So calculus is negative 32 feet per second. That's first thing. Second thing, let's introduce what's a free fall equation. A free fall equation is given by this function. S of t equal to negative 16t squared. And that is, my fault. For right now, it's going to be negative 4.9 t squared. Now, you're going to say, where's negative 4.9 t squared come from? It's coming from this equation, is S of t is equal to half of gt squared. G is 9.8, so half of 9.8 is 4.9 t squared. But in calculus, we don't use 9.8, so we says that's equal to half of g of t squared, so it's gonna be 32. So S of t is equal to negative 16t squared. Now, using negative 16t squared in algebra 2 classes, this is a very common thing to see. That's a free fall. Does everybody understand the free fall equation? Yeah. Let me give you a table to show you the free fall. And this is what I show. I'm going to show in actual scales. So t is equal to 0, 1, 2, 3, 4, 5. I'm going to plug in each 5. Now, S of t is going to give you a position at giving time. So S of t is going to tell you. So what happens if I plug in 0? I'm going to get 0, right? What happens if I plug in 1? Negative 16, right?
Oh,
I think there's a PSAT question about similar like this, I think. According to TikTok, there's at the table in the sales set up. Negative 16, how about 2? 2 square is 4. Negative 64. Negative 144. Negative 256. And negative 400. Guess what? 400 free ropes within 5 seconds is long enough. So next time, if you ever have to jump out of the building for some weird reason, not saying you should. Yeah, you got to calculate first, yes. So when you jump out, then you have to know in 1 second, you're going to fall. Now, each square box is going to represent 16 feet. So this is the 1 second. And this is in 2 seconds of time, is going to fall 48 feet. And 64 is going to be, this 144 is roughly 9 rectangular boxes. So, hold on, this is different color. So, 9 boxes. So, this is 3 seconds. Now, in 4 seconds is going to be what? 256. But 256 divided by 16 is going to be 16 squares. So, 1, 2, 3, 4, 1, 2, 9, 10, 11, 12, 13, 14, 15, 16. So, in 4 seconds, it's a fall that much. So it's going to fall faster and faster and faster, okay? Or it's going to cover more ground in each second as it increases. Does that give you a picture of what happened now? Okay, and 16, this is 25 spaces. So let's say 25 spaces. We already covered 16 spaces, so we just need 9 more space. So it's roughly right here, 5 seconds. So this actually in scale. I actually draw it in scale so that way you can see what's the things in the picture. Now, I don't know anything about photography. You can take a photography. That's how, you know, people doing like a glowing stick dance, and they can see, they can draw something with the glowing stick, is to slow down the frame rate, right? Yeah. Slow down the frame rate. You decrease the frame rate. Now, if you do that for the 5 seconds, you're going to see the ball is going to drop in like at different times. And you're going to see that ball is going to get further and further apart. That's when you dropped. Do you understand so far? Sorry, that's just all the background knowledge. Okay? Now let's talk about calculus. The calculus has something called average velocity and instantaneous velocity. So let's start by talking about the difference between average velocity and instantaneous velocity. So, so this is a free fall. Okay, so now we're going to go back to talk about something else. So I'm probably going to go back here. Let's just say, hey, if a man is at here, 0, 1, 2, 3, 4, 5, 6, 7, 8. And he's right here at 8-mile mark. And he's here at 4-mile mark. And from him to get to the other one, this is t equal to 0 hours. And this is t equal to 2 hours. So can you find out how fast this man go? Or what's it mean called like average velocity? How do I find the average velocity? If you guys already take physics, you should know how to find average velocity. So average velocity is what? How do I calculate it? In calculus, we also know as average rate of change as well as average velocity. So how do I calculate this? How fast this man's walking? If t equal to 0, he's at 4-hour mark, and t equal to 2, he's at 8.
Difference in movement over difference in time.
Good. You didn't take physics. You already do a better job than physics student. Oh. Change in x over change in time. That's good. So that's the delta x over the delta time. I respect the honesty though. Honestly, at least you have the will to go look it up. Some people didn't even go look it up. 2 minus 0. So that's going to be 4 over 2. That's equal to 2 miles per hour. And that's called average velocity. So if you want the average velocity, it's changing the displacement over changing time. Take the difference of two destinations and then subtract them. If you subtract them, you divide it by the total things. Are we okay here? Okay. What's the difference between instantaneous velocity? Instantaneous velocity is, so I'm an old man. I probably walking really fast between 4 to 5 miles. And between 5 to 6 miles, I kind of get tired, but I still can say I'm not old man. I'm just going to keep on trying to walk. But by the time when I get to 6 miles, I'm going to be like, I'm out of breath. And I'm going to slow down. So I don't always walk at constant speed. So like you're driving, you don't always drive in a constant speed. You cannot put a cruise control in your car and drive from here to Gainesville. There's no way. Because you're gonna stop in the stoplights, right? You're gonna stop and get gas. You're gonna stop to get doing something else, eat McDonald's, whatever. You will have to stop somewhere, sometime. And when you're speeding up, it's different speed. So you cannot say police pull you over and you driving 80 miles per hour on Conroy, going through Windermere. And you know that what's gonna happen. If you drive 80 miles going through Windermere on Conroy, you're gonna hit that traffic, right? Yeah. And at 4 o'clock in the afternoon, you're gonna see that big traffic. And police are gonna pull you over, say, why are you driving 80 miles per hour? And you're gonna tell police exactly like this because your calculus teacher told you to do so. You say, look, policeman, with due respect, my average velocity is way smaller because at first I'm driving 80 miles, but when I get to the traffic, I'm gonna drive 2 miles per hour. So my average velocity is somewhat like 35 miles per hour. You should not pull me over. If according to logic that you are never able to get by because the police like you are just full of shit. Because what they pull is something called what they pull is something that they call an instantaneous velocity. So at that moment, at that particular time, you are driving 80 miles per hour. They don't give a shit what happened afterwards. That when you're driving 2 miles per hour or before that, you get into the stoplight. They care about that moment at that particular time. Now, that's called instantaneous. I do not know how to spell instantaneous.
INSTANEOUS.
I would definitely ask a brown person to ask how to spell them. All right. There's no white people ever went spelling bee, right? Sorry, that's YouTuber. Don't listen to me. I'm not racist. That's how you're gonna get me canceled. If you ever don't hate Mr. Ye, there's a clip right there. So instantaneous velocity is a velocity at particular moments. At particular time. And some people says that's a tangent line, which is also a very good. Michael Remington says that's a tangent line as opposed to secant line. Secant line is average velocity. Tangent line is an instantaneous velocity. Now, I'm covering a lot of stuff, so I'm going to go cover back and forth. Now, what's instantaneous velocity in calculus? It's very easy. If you take a position function, and then you take a derivative of that, that's equal to instantaneous. INSTANT. How to spell Russ?
ANEOUS.
Instantaneous velocity. So if I take a derivative, I'm gonna get instantaneous velocity. I can take a derivative again. Mr. E, why do I need to do a second derivative? What's the point of that? I think Danny asked that before. The second derivative of position function is gonna give you acceleration function. So if I take the second derivative, and that's equal to prime of the first derivative, is equal to a of t. It's equal to acceleration. In physics, you can actually take third derivative, it's called jerk, a jerk motion. Okay, I don't know how to explain that part, so I'm just gonna give up on that. But you can ask Mr. Suck because I have no idea how to explain that. So they got S of t, V of t, and A of t. How do I remember it? S, V, A. If I go in this way, I'm taking derivative. If I'm going this way, I'm taking antiderivative,
Integral.
which is integral, yes. But we're not gonna get that yet. We're gonna go only study one section first. It's taking derivative. It's gonna take it from position to velocity, from velocity to acceleration. How much time I have? Good. I'm gonna explain the rest of them. Now I'm gonna explain this question. Now I'm gonna build this question, and this build this model this projectile function. So I have something is going up and come back down. So this is called projectile. Now projectile equation is a little bit different. It has a free fall part, which is negative 16t squared. So this is responsible for free fall, right? That you cannot control over. But there is another part is how you throw up this. The moment my marker left my hand, it has some type of velocity on it, which is a positive velocity. So it's going to be V0t, right? V0t. This is how fast you throw up. Not throw up, it's throw up. Okay. And then this part is going to be S0, which is the initial positions. The reason why they have not a 0, V0, that means initial, when t equal to 0. What's my velocity? The moment the marker left my hand has some type of velocity. Do you get that? So in this case, this is going to be a projectile. Now let's go back to this question that we did at the very beginning. Maximum height is 3164. Take a 14 second. How high is the object at t equal to 1? We're going to build this equation, believe it or not. We're going to take this position function. We're going to take derivative. S prime of t. What's derivative of negative 16t squared?
32t.
Negative 32t plus what? No.
Yeah.
V0. Now remember when I throw a marker, when the marker at the highest point, what's my velocity? So V of 14 is equal to 0. Does that make sense? That's what we're doing horizontal tangent for. Taking derivatives that are equal to 0. Does that make sense? Now I'm going to set that equal to 0 when t equal to 14. And the V0 is equal to 32 times 14, which is equal to 448, if I did it right. So I actually find out, if I take 14 seconds to reach maximum height, I actually find out what's my initial velocity, which is pretty good, right? We haven't solved the problem yet. We're going to go back to the position function. Plus V0t, which is 448t. Now I'm going to plug in 1. That's going to be negative 16 times 1 squared plus 448. The answer is 432. Beautiful, beautiful question. Did I ever use maximum height? No. Yes.
What did you do with V of
B is V naught?
yeah,
I solved for it. I said velocity is equal to 0. And I plug in 0 because I know at highest moment I have 0 velocity. Not only this, I'm going to show you the most beautiful part of this of all, and then going to put everything all in together in one picture. Look at this. 448x. Negative 16x squared plus 448x. I plug in the calculator. And I'm going to click on the maximum. Do you see that coordinate? Math work. Physics work. Now, who says SAT doesn't give you extra information, I call that bullshit, because 3164 is extra information. I mean, you don't have to use it. That's why I call it extra. But you can use it to solve it, yes. But 3164, it doesn't need it. Okay?
I have 45 seconds to roll.
5 seconds.
Okay, so yes, Reba.
How would you find the maximum point of that graph?
Huh?
How would you find the maximum point of the graph algebraically?
Algebraically, you're gonna do negative b over 2a. And you're gonna plug in.
Yeah.
Oh, actually, just plug in 14, actually.
Why?
If you plug in 14, you're gonna get a maximum height. Now, here's my next question. How long take it to fall on the ground?
14 seconds.
What?
14 seconds is at the apex. 28. So it's like 28 seconds.
So 28 seconds to fall back on the ground. Does that make sense? Because 14 seconds to reach the maximum height, it takes 14 seconds to drop back down. No, that's not a question. The answer to the question is 432.
Wait, why did you find the derivative?
I find the derivative is because I want to find a velocity function. Because the velocity at maximum height, velocity is equal to 0. It's crazy, right? How?
Luke Davis was explaining. He was saying the same thing you said. Like B naught. Like he had the equation in his head.
Well, Luke Davis is Luke Davis. He's a machine.
What are you saying? You're not using like he wasn't using like 3136. He was using the formula in his head. I was like, dude, just use 3136. He's like, no, just let me tell you. Explain.
Luke Davis is special. He think that at the same age, I'm owning 1% of Luke Davis. At the same age, we both at 10th grade, I'm owning 1% of him. Sorry, that just I told him too. I says you have a great future. I mean, you just need to make sure you're persistent at doing something. Make yourself out of. He will be going to MIT because I try to tell him to go to MIT. That will be the school for him, because normal school is too easy for him. MIT will be the subject of place that they can go and they can become the best.
Like Rain Man.
Huh?
Like Rain Man.
Well, he's not the smartest person I ever seen, though. I think a third grader can do calculus. So I have seen some smart people in my life, and Luke Davis is up there though. He's a number 2 right now. Number 1 is that third grader kid.
No way.
Yeah, third grader.
Smarter than like Sheila.
The third grade kids was able to. He was able to solve. So I told him, I says, hey, I want a 9-digit number put in the checker box in the tic-tac-toe box. I want it 1 to 9 without repeating, and
Each column and row to add up to 9.
add up to be the same number.
Say no, but you don't know what the number.
No repeating and no combination. And Matthew was here, right? He solved it.
Did Max get that too, right? I remember Max tried to find this.
Which Max?
Max DeLong.
Max DeLong, he's also had the strength. He has a very he asked the right question in math. So there are people who can learn math, and there's people who ask the right question in math. You do too. Matthew doesn't ask too much question, but he has a very creative mindset. Things that nature, and
So when I was doing the same problem, what I did wrong was what I did is actually I put into vertex form.
That's what Marco did, and he got 70.
Marco who?
Marco, he got 70.
Who's Marco?
Marco.
Let's see, here's my problem.
Here's what he did, right? So like,
I have a question.
Sure.
Is there homework today?
Yeah, they are. I'm gonna post the last test as a homework because I feel like last test everybody did bad. But I'm gonna post the answers also,
Last.
so that way you know which one to work to. You missed the first question, just so you know.
smart.
The rest is okay. It's better.
As a homework grade.
Only the first question.
There is no percentage.
Okay, if you want to know what's on homework, you can post on this on group chat first. But that's basically the whole test is the homework. But I'm gonna post the answers also, so you can. Yeah.
Is the test going on this quarter?
No, I can't. I was very sick yesterday. That's why I left early yesterday. Yeah, but I'm gonna give you the right answer this time.
No, it's 32. Well, Mark, no point. Yeah, but it's like a physics question. David, I'm explaining this.
For the falling off the like, announce it wouldn't continue to accelerate. We wouldn't be able to. There would be a limit to where.
Yeah. So what happened? He threw an object. Hold on. Repeat your question again.
If you drop it would accelerate, but at one point it would stop accelerating because there's no
Dude, I think I got 11.
would be able to accelerate to
Okay, that's a great question. That's a great question. So with acceleration at infinity, so I saw there's a physics professor did this question before. It's very interesting. He said hypothetically, can you drill a hole throughout the earth like this?
Yeah.
Like just through the core like this, right? So he says, I'm gonna propose a new idea to travel across the earth. He said just fall into this hole.
What did it oscillate? Or like good stuff?
No, but it's actually interesting though. So when you're pulling this way, the gravity is pulling you to there, right? But you're gonna reach at a terminal speed at here at this.
Yeah.
Once you get past this point,
It's gonna
the
go
thing
other
is
way.
gonna pull back. So you can actually go into the other side and have a zero speed, and all you guys take one step forward.
Oh, it would be perfect. It would be perfect. It would be, yeah.
That's pretty cool. And he said, so yeah, I thought it was like so Walter Lewin is one of my professors that changed my life as a teacher.
I'm telling you. And once you're on the
And he proposed like it is true. So he did the calculation and he proved that it's theoretically, it's possible. I don't remember.
It's the same reason. Like this, your
Yeah. So he pointed out something that's very crucial and very profound. And Walter Lewin is the best professor. I'll show you what Walter Lewin do. So here I'll show you.
your altitude also. Because if you were like slightly lower, when you first jump in, then you go back to the other way.
How the hell is
And then you have a
Yeah, I don't know. That's interesting. All right, so yeah. Yeah, of course.
I knew it was negative.
I know about
Oh,
that.
I'm even get beat up by barely. Yes. We know it starts. Wait. Think about that. This is really cool. Because you know it starts from this.
So I don't know how to share this.
Yeah, we know. Bro, we know at f of 0. Zero.
Oh, this skin.
F of 0. This has to equal 0.
Okay.
Any number that when you multiply this, it will equal 3,086. I'm really gonna
Oh yeah, I saw that video already. It's a very good game. I saw it. No, that's not Fabiano. That's against Ray somebody.
Oh yeah.
He just lost this game. He got destroyed in 28 moves. So now people's gonna start saying he actually cheated.
Is it like because we know this is
I'm actually curious.
between all these we don't know what it is.
That made
Okay, here's what I did wrong. I wrote out this formula and I tried it with negative 9.8 because I misread. I thought that was in meters, but it was 32.
It was 32.
Or it was 16. I literally did the whole formula with negative 32.
Okay, so I don't know if you guys like math just a little bit more, but that question is very, very life changing. I think that question really blow people's mind. Like, how do you not need the maximum height to solve that problem? It's actually a very, very cool problem. Very, very cool problem.
Physics problem it is.
Yeah, business problem.
Do we have did you want the whole-
Yeah, but I'm gonna do them then.
No, it's just algebra.
No, but it is algebra.
Like this is just
Bro,
algebra.
technically it is algebra, but you learned it in physics.
I learned that from pre-calc, so.
That's freak out.
Oh, did you get it right?
No. I didn't run the equation, I got questions on the side, I tried to do it, and
He had that in his. Yes, he had that in his.
You see something and you memorize on that.
To be honestly, like last year when I taught BC, I just think Luke Davis is. I just grade his paper.
Yeah, auto graded.
7, maybe 800.
It's a pretty amazing.
everyone's doing that.
With the arm on.
Good, bro.
No, that question's 256.
No, I think that's wrong. I did like.
But did you guys know how to do it?
I didn't, wasn't a question on the thing.
I think the point was he couldn't time it.
384.
Oh, I think he did do another invention. We're trying to find the arm thing where he just found the sensor and he did exactly like you don't need to do anything.
84.
And he tried to use like
Okay,
so
actually, you know, you need to know something.
and
Yeah.
I didn't rotate it. So even yeah.
Yeah, let's see it does.
Yeah.
What do you even get? Yeah, see, first you divide it out to get rid of the prime.
So that's 6. So it'll be 64 square root 3, right?
And you divide it out
Area of a triangle.
1/2
is- No, it's actually square root 3 over 4. So S is
Not like-
equal to
is that like-
16
Oh,
and
I like
16
Aaron.
square.
Aaron.
Aaron's law.
Okay, wait.
Not Aaron's law. So I'm gonna show you the equilateral triangle that has the S here, and here, this is the S over 2. Now this is the perpendicular bisector, the angle bisector is 60, so this is S over 2, the height is
Oh, I get it.
So then you try to multiply the S times S square root 2 square root 3, that's equal to n times half, because 1/2 is 1/2 base times height, 1/2 base
It
times.
doesn't have to be on my thing
So
now.
that's 1
Yeah,
4
just
square
like
root.
this, right?
Yeah.
So then that's equal to 16, 1 to 16 to square it, 256.
Here's how I think that, bro. Here's how I did it. Here's how I did it. Look, can I lost him. So once yeah, that here is a little bit interesting. How did you get this though?
I already showed you. This is equilateral triangle, this is the S, right? So this is the S. If I break the equilateral triangle to half, it's called angle bisector. This is 30, it's still 60. This is S over 2, right? Now spacing of 30 to 60 degrees, square root 3 of this.
All from YouTube.
So S square root 2 times square root 3. That's going to be this height. So half
A constant
times
amount
S
of money
times
and
height,
gives it away.
that's
and
the area of
no
triangle,
point.
which is square root 3 over 4.
And then you do 1/2.
You know, I think yeah.
All right, wait, can I show you guys how?
Yes.
So here, that's actually really nice, but
He deserves all the extra.
Yes.
where is this?
I'm waiting, Daddy.
Oh, I was so disappointed when I found out he.
You're my daddy.
I don't know what is it. North Carolina.
Oh, green
No,
daddy.
I don't think.
I thought he literally always.
Daddy.
I thought it was script.
I was like, bro, just come down.
Oh, I heard about that. That's on Shark Tank.
I just found it right here.
Hey, Mr. Brown,
That thing is. Wait, so they actually do that? I want to take it home.
Yeah, I would always be that you like.
Oh, clean your screen.
I was like, why did you get this from the exact location, like finding patterns and stuff, and tracking that?
I never get a job and like, yeah. Mr. Beast is your income. Mr. Beast gave me a house. Mr. Beast gave me a house. A car. I'm good. I'm all set. I've only seen the white one.
Because if it was like this, the wine
He asked for a glass of water from a restaurant. And he
that's good.
just for the glass of water.
I need
And then eventually
you how to do the first question.
Y intercept is when x is equal to 0.
Which is you know how to do.
This is y intercept, right?
Yeah, I don't
It can be anywhere here, but the x has to be 0. So we just plug it in here and watch it.
Oh yeah.
If you know the graphic,
Which
like,
one?
I just forget to
Sorry.
That one. Okay, plug it to it's using the plug in too.
Why is why instead of when x is equal to 0? If you think about it, it's 0, comma 3.
If I hate
Right? The x is always 0 whenever it's just on the y.
I always have really
Like, this is x equal
because
to
well, I think about a lot. I would give you a warning. I just want yeah, you just let other people.
No, you just put it find an inverted to 0, you just plug in 0. You try to find a sign, you just plug in 0.
I know. The constant is supposed to be the y instead of
I'm gonna try to explain this.
Alright.
I really want people to get
First,
this.
first thing you
I don't
do-
actually want people to walk
I
back.
divide it again.
Joke.
So I divide the triangle again. So I divide this by so then we get 32.
When I asked you to try to solve a
Yeah.
problem,
But now here's the thing. We have 30.
and I think I was upset
Right?
when I told you just do it on a paper. I don't want you to.
So this will be
because I want
It's
everybody
like my
to do it all.
sentences are-
So when you told me
Because
with the
if we're using
paper,
products
yes.
and
Yeah,
then
that's
we go in and fix it, we're gonna
Yeah.
then we keep it on one thing.
Now,
Yeah, but I think you don't like to put it on the board. But you say, no, this is what.
in order to find this,
And that's
this
very
area.
good.
So what you do is this divide by 2. Base times times.
So
Then we get
What I asked you, follow my son.
equals
And then we're gonna
30.
do the,
Don't follow.
then we're gonna do the chain rule.
So I usually break.
So we're gonna do the
I usually use. I will tell you like
X equals 8.
You are the
What does that mean?
you are I want to get.
So you multiply by 2.
No, I want to get
Yeah. Right. This. So it'd be like 2. Okay. 16 and 16 times 16, bro. This is 9.
It's just when that moment when you tell me it's a waste of paper. And that's the moment when I'm like, you know, that's enough. I want you kind of just say, okay.
What do you want to put this?
But last year, David, you're not like this. Let's read more.
Well, I did this. I got this was put in 16 and then 3.
You are is you are trying to solve a problem. Also, it's
Gonna be an SAT.
Yeah, that's the thing.
Actually, you're doing them at the same
I got
time.
an 8
But it's not always.
How long would it take to solve?
I was like,
Yeah, no, but how long would it take it to solve?
And you did something that would just kind of like.
Yeah, you're going crazy for
you're gonna freak me out. But then like,
So you find, you're finding the, you know, your chain rule
And
is basically this.
you start talking to yourself.
Oh, I hate- yeah.
This is chain rule. This right here.
yeah, but
And I, the reason why.
Chain rule is the front. You put.
Whoever- whoever said ball, right?
Because
whoever called
that's
this,
a lot of
It was
people are
nice.
joking, yeah, but
This is chain rule.
I'm serious. People who are
Reason you
serious.
multiply by
something.
And I thought you could.
Oh.
So right here, this is the rhythm. This right here is.
So I would like to say,
I don't know what it
You're
is. Yeah.
doing.
Why is it so
Prime.
difficult sometimes?
So you got X equals 1, right? That doesn't make sense. You see what I mean?
Times X.
Like when you plug in 1, what's the square of 1?
Oh, I see.
Yeah.
So what the answer?
Prime
No one
of
knows,
X.
bro.
I just wrote something.
I guess that if you're my.
Oh, it doesn't exist.
Yeah.
It can't exist.
This is a-
Yeah.
I mean, I can't say whatever.
Oh, that's not really.
But
Yeah, didn't that yeah, it can never be a negative.
Oh,
So you do chain rule in order to find.
Oh, yeah.
Wait, let me see one of them marked. I'm gonna try and do it wrong.
So this right here, where I. That's-
What the y
Or
SAT can never be.
The y.
First response on SAT is never
that-
negative.
No, that's more
that's right here.
Negative signs above.
Oh, you're trying to do this one?
Executed X. So we're basically.
Oh, yeah, exactly.
following the equation.
That one's nice. That's the one I missed the
Okay,
issue.
so we keep going, right? Then we go in then we.
Yeah, like,
the
thirty
part-
eyes
the
square.
part will have to go back.
Look like that one.
Do the same
Yeah.
thing, but for the other side.
This is like that one.
Right?
Look at this.
So now we have to do find G.
What?
Right?
I get 30.
We find
Yeah.
some effect
That was-
by doing the chain rule.
30 eyes.
You wrote it?
All right, so this question, can somebody post this on the group chat and just I don't want to post on Canvas because it take too long. I gotta write BC homework.
Just this? Just the first part?
No, this is the whole test.
Oh.
Post this whole thing on the test. Just say I will post on the Canvas. And make sure you do the homework. No, you're supposed to go through them all, and I'm gonna give you answers, and that way you can check whether your answer is right. Because it's the same test. It's the same exact test. But a lot of people didn't even get a chance to finish it. I want you to actually finish and understand it.
Nothing. That test though, I kind of freaked out.
This guy's so passionate for math. It's almost beautiful.
Wait, me?
Yeah.
Well, thank you, bro. Thank you.
Yeah,
No,
you
math is
really
good.
are-
I wish I was that passionate about math. But without passion, there's no point. Like doing that.
I first negative one. Hey, did you want to start doing that? I'm gonna start doing an extra sheet of paper.
Let me
And, like,
What do you mean? Like
I'm literally just gonna use another sheet of paper.
that's true. Like I overspilled in so many questions.
Dude, you know what my thing is? When you're writing so much stuff, you just feel like that's easier.
That's
Not really have to be enough.
It doesn't even that. I'm gonna have to like restart my problems. That's why it took me so long.
That's fine. I don't know. I'm starting out all this test.
the most negative number being back.
Strategy.
Xavier and Harmon, this is the first homework question here for BC.
Yeah.
So-
you're gonna factor out.
This just becomes positive 42.
Yeah, no. Because that's the most negative. Because if you have your like common here, 42 plus 20.
Dude, why?
So we're gonna do the factor out.
9 to 7 is 16x squared. Bro, look at this.
Okay,
And 20 plus 4, 140.
but we what else do you see is common?
But bro, let me explain to you the percent change.
2x minus 7, which is 20. Exponent is divided with your Yeah, so we're gonna divide that. X minus 7.
Okay, so it's like,
So at this point, we're gonna do versus So
so this is
after
the
you go
question,
into
right?
bracket,
Gen 1,
yeah.
16,
Guess what? Here,
2.
No, I know this. I think that is so.
Yeah.
Times 3.
Oh, yeah, Matt, you
And
understand.
then factor out 2x.
No, that one I understand. What you said.
You're left with 1.
Close to the.
And then you have
Thank you.
4 times 3.
Just say I will post on Canvas later. Yeah, I'll post it today.
Okay.
I already have it.
And you left with 3
My dog.
times
don't know that back.
2. And then you left with
So how was the PSA?
I know that one. I know that one.
I don't know how to manage my tests well.
Even
Even though the test was not.
when you factor out
That right? Also, that was the
you still need to keep
I knew that. Right? And I went back to it.
No, it's actually 8 minus 3.
Tell you guys. You guys, you know,
Remember the January, like, January 1st,
Oh,
2016?
you know how to do that.
Yeah. What's
But serendipity, though, just gets live action.
So back to your equation, right?
You feel a little tingle then.
I like the photos of the
Yeah, it's in the past.
Okay, I'm gonna like practice.
He has the shit you go on his side.
Bro, what are you talking?
Thank you, Mr. You guys know the,
Huh?
you know the relationship, right? So,
I think you'll be a good person to look up Walter Lewin's lecture.
I'm about to say, but we can test that.
so you said.
Walter Lewin. Look it up. Here, come here. We look up together.
Like really sus.
Just like
No, he's an MIT professor. I wish I have him. Can you take a picture first? I'm gonna post 5 more questions after that, okay?
Like, the scale that's
What is the question after?
I'm gonna post 5 more questions after that. I wanna show.
This on the group chat.
Not yet. I'm gonna post everything first.
Oh, no, this is a hack. This is a hack. Like 1 to 5.
Have you been improving at chess, Mr. Look at
Yeah, but I suck. I just get killed very easily because I get upset very fast.
Do you want to? The problem with the thing that makes this so hard is there's no excuse.
That's true.
And like, in a lot of like real things, there's a lot of blocking, a lot of games. Versus in chess, it's just literally all skills. So yeah, I just back in the head.
Okay, so you guys, I want to show you a video about this guy. This guy is a physics professor that inspired me to be a better teacher every
I'm
day.
in the midst of applying for residency right now. Grammar means
So this guy is 80 years old. He teaches at MIT, and he's a guy that I doubt very putting 100% of the effort on the teaching. So this is one of his lecture, and it's also known as the last lecture.
Over your lifetime, you get 20
No, he didn't die, still alive. So he trying to tell you, shh. Okay, go. Tunisia is the only person can talk. So yeah, go ahead. Did she understand? Okay. So this is one of the teacher that inspired me to want to be a very good teacher. He's a very good teacher. So he asked in this lecture, he asked a question. He asked whether this pendulum swinging is so pendulum swinging, it has a period. From things going forward and backward, that's one period. How long it takes to get one period? Now, here's a question, those of you guys take a physics already, you should know. So Harmon and Xavier should know this already. So it doesn't matter, it doesn't matter of how heavy the ball is. Does the ball affect the period of the pendulum?
No, swing.
Period of time is taken for it goes forward and backward.
No, it doesn't.
Sorry, I can help you today, but today I was very exciting about the topic I'm teaching. That's good.
It doesn't.
Huh?
It doesn't.
Okay, so here's my next question. Shh. If you say it doesn't affect it, now does the angle, like I'm talking about the angle of this pendulum, that just say if I swing it to up here, does it matter? Like if you move the ball up a little bit higher.
Yes.
No.
Yes?
No.
Oh, yes.
Okay.
Did the angle affect what?
Does the angle affect things?
No.
Okay, so here's the next question. The angle, it doesn't matter. The weight, you say it doesn't matter. But what matters? How do you change the period of the pendulum? Besides what?
Maybe like rubber shape.
Maybe shapes?
Is it the power of friendship?
Huh?
Is it the power of friendship? Oh my god.
Bruh.
Wait, is it velocity?
Gravity.
Wait, what is that?
Size of the pendulum.
No, size of the pendulum, I will show you. He actually did it. So he calculated a period to take to go in through like back and forth 10 times. And he will actually do one with changing the angle. So it will roughly 46 seconds. If you see this growing to 46, that's without things on it. But he says, you know, in this moment it's 46 seconds. Right? And then he said, does weight matter? So what he did is, remember he's 80 years old. It's really hard to squeeze your leg together at 80 years old. But he do it because he loved physics so much. No, you can do it. That's 5 questions, you can do it. So what happened is thing lost. So He did it again. Now remember, those people watching is our MIT professors. They're not students. Because some of those professors are his students.
Can you calculate faster?
They're all professors.
No, they can't come faster. One more, man.
Now that's a teacher right there. That is a badass teacher right there. What a guy. I mean, this guy just like I have a full admiration to this guy. Remember it was 46 seconds? You can do that with calculus. I mean, I can.
You should put like a string in the roof and you.
Me jumping off?
Yeah.
Yeah, you should give
I will
us
do
more-
that. I will totally do that.
Yeah, you should give us more extreme visuals.
So this is a 10T water Lewin 45.88.
Plus or minus 0.2. Period. 4.
Yeah.
5 times. Plus or minus.
Oh, you already did that?
0.02. It works.
Is that amazing, teacher? This is one of the things that he does a lot of cool. This is all of his famous lectures. This lecture is super cool. So if the conservation of energy holds true, that 10-pound ball
Oh, this is the clickbait.
that 10-pound ball can crush his skull if he insert any force on that 10-pound ball. And can, because the way he did it is there was like actually a glass before, and
Now comes an experiment.
so if you put a force on it, and then that's gonna break his skull. So I mean, he did phenomenal shit. This guy is just truly amazing. I have seen him create electricity with a bucket of water, and a bucket of water he create electricity. He dropped two hollow cans, drop the water consistently, and create those two cans together. And on the part is they drop the water, do a hollow can. Like the water can go all the way through, and it creates current, and that current go to the middle, it will spark. It's crazy. It was blowing people's mind. But this guy was like truly amazing teacher. Walter Lewin was like one of the best teacher I ever seen.
He was a professor at MIT.
Yeah, he was a professor at MIT. He did all his lectures. If you want to understand how physics work, look up this guy. I think Danny, you are interested about looking up those stuff, so that's why I introduced you. I thought this guy is a phenomenal. Like he does some cool stuff. That's amazing stuff that point people's.
I watched. Actually, someone who did chemistry. I want to find his name. He really presents really good.
No, this guy is a. I mean, if you watch his lecture, he can actually prove to you like if you laying down flat, it's gonna be I think shorter. No, you stand up tall straight, it's gonna be shorter. You laying down flat. It's pretty crazy. I mean, he proved to you and how things work. It's just like truly amazing. He does music notes. He does a lot of things that's very cool. I think that's just phenomenal. But anyway,
I'm not sure where he presents this, but actually, his name is like Andrew Sizla, and he gives a lecture to a bunch of people about how chemistry works. It's really interesting, actually. Yeah,
send it to me. I don't know. I've never seen that guy.
yeah, it's actually really good. Yeah.
But this time you gotta do it right. because a lot of you guys didn't know how to do it right on the last test.
Watch that.
I will post the answer today too. Huh? AFT is acceleration. If you take a derivative of velocity, it's gonna get acceleration.
Oh. So how do you use that one?
That one we're gonna use some different case tomorrow. We're gonna talk about that tomorrow.
Take it out. Between -1 to the -2.